Hi everyone, welcome to the presentation on our paper Polarity and Subjectivity Detection with Multitask Learning and Word Embeddings. So this paper I wrote with Professor Eric Cambria and Dr. Ranjan Satapathy during my internship at NTO Singapore. So let's start by understanding the multitask learning or MTL. So MTL is a machine learning approach where multiple related tasks are learned simultaneously using a shared model. This approach leverages the commonalities between tasks to improve the performance on each task. Using MTL, when multiple tasks are learned together, the model can discover common features and representations that are beneficial for all the tasks. This means that the knowledge gained from one task can be helpful in improving the performance of another task. So, training on related tasks helps the model to generalize better on each task, and that reduces the risk of overfitting and improves the robustness of the model. So, in our paper, so we have applied MTL to enhance accuracy of two complementary tasks: polarity detection and subjectivity detection. Okay, so yeah. So polarity detection is basically determining whether the sentiment present in the text is positive, negative, or neutral. On the other hand, subjectivity detection involves identifying whether the statement is subjective or objective, that is, opinion or a fact. So subjective statements express opinion or feelings such as movie was amazing, right? And it's also a positive statement. So these two tasks are complementary because subjective tasks, like subjective sentences, are often more polarized. They can be, and the objective sentences are. There is a more chance that the objective sentences are facts. So yeah. So let's take a look at the model architecture now. In our architecture, so our model begins with tokenizing the input text using BERT embeddings. So BERT tokenizes input and generates embedding of with dimension L cross 768. So this was like pre-trained BERT and we use pre-trained embeddings where L is the maximum length of the input. So the embeddings capture rich contextual information from the input sentences. When we wrote this paper, when we were working on this, BERT was the state of the art. Then the second layer is BiLSTM. The BERT embeddings are then fed to bidirectional long short-term memory layer. This layer processes the embeddings to capture contextual information from both the direction, ensuring that model understand context in relation to their surrounding words, not just from one side. Okay, then comes the main self-attention mechanism. So this mechanism basically helps prioritize the most relevant words in the task it does it by assigning higher weights to the important words. Okay, then comes the main thing which is making this model a multitask learning model, NTN, neural tensor network. The outputs from self attention are then fed into neural tensor network. The NTN is, so basically we have BERT embeddings for polarity and then subjectivity, and all these things are training simultaneously. Then there are all the self attention outputs are going into NTN, and it integrates features from both sensitivity, sentiment, and subjectivity tasks, enhancing the like improving the overall performance of both the tasks. Then comes the classification layer. So there are two separate classification layers, which uses softmax, and yeah, the one is for sentiment, positive, negative, neutral, and other one is for of opinion or fact. Okay. Yeah, so that's pretty much about our model. Then comes the data set. So we have used Pangli data set. It's a very famous sentiment data set. So for polarity detection task, we utilized a data set containing around 5,300 positive and equally negative sentences. To ensure the balance, we randomly selected 500 sentences because for the subjectivity task, we only had 10,000 sentences. Yeah, so this is basically the accuracy and loss plots of our models. Now comes to the result part. This table showcases various models and their effectiveness in subjective and polarity detection tasks. Our multitask learning approach combined with word embeddings outperformed the other models in both the areas. Specifically, our model achieved 95.1% accuracy in subjectivity and 94.6% accuracy in polarity. So, in comparison to traditional models like Sentic, Addison, showed strong performance but didn't match the accuracy level we achieved on the same dataset. So, the multitask models with shared layer are also performed well, but our approach demonstrated the highest accuracy, proving the advantage of leveraging shared representation and task interactions. Yeah, so this is pretty much about my work, and thank you so much.